Hello, friends. Happy to get to spend a little bit more time with you today. We're moving into chapter 3, and today I'd like to work with you on the second section of chapter 3. So let's go ahead and let's get started. I'll go ahead and share my screen. Um, so starting from scratch, I feel like is usually the best place to start whenever we're going to work through these things. Bear with me, I've got 5 screens. Hopefully you can see this. If not, please send me an email and let me know that the video stinks and I'll try to redo it. So we're going to go to SWOSU and get logged in. All right, so it still recognizes me because I've logged in just a couple minutes ago. Going in here to Canvas. Go under courses. I should probably read those things. Here we have discrete structures. Now let's take a look at the schedule of what's coming up. So we've got homework 2 due on January the 26th, and we're going to have the exam on Wednesday. So let's go ahead and open up this new tab. And here's the problems that we need to work through. And so we need to work through section 3.2, 7, 8, and 9. And I'll be honest with you, I really don't remember what those are right off the top of my head. So I'm going to open up the syllabus in a new tab. And I remember the syllabus has down here a little bit shared folders. And so first thing I'm going to do is I'm going to open this up. And we can go use the link to go down to this. All right, so here's the 3 questions. And it says, find the least integer n such that f of x is on the order of x to the n for each of these functions. Okay, so I've got to admit, it has been a while since I've done big O notation. And every time I do this, I get a little bit better at it, but it does still confuse me a little bit. Okay, so the thing that I want to do is I'll come in here to Dropbox, and I can see we've got all of these files. Now, I also on my computer pulled down all of these files, and so I can just come in here to my office computer where I have these pulled down, and this is and here's our class files. Oh, I think I grabbed the wrong one there. Oh, yeah, I did. Student resources. And as you can see, we have this 2012 version of the PDF. Okay, so this is a good example of, I think I'm going to need to do a Google Doc again to kind of keep track of this. So we'll do a new Google Doc. And I'm going to call this one, I think I'll call it okay. So there we have that. I'm going to drag this off to the side for just a minute. I'm going to grab this image and I'm going to paste it in my Google Doc. Okay, so let's do problem 7. Actually, okay, so for part 1, let's just walk through the 5 pieces that I need. Summary question. And my answer for this is use big O notation to help demonstrate how problems are going to scale. So even though there's 9 different parts, all I'm going to do is just write one sentence. And the idea behind this is, that it's all kind of in the same thing. And this is kind of your level of understanding. Hopefully you can collapse this down and talk about it a little bit. Okay, so now we need to have references. And then, of course, we're going to need assumptions. And then we're going to need to show our work. And then why we believe our answer. Okay, so we've got our pieces now laid out for what we're going to need to go do. Now we need to just start doing it. Okay, so I'm going to try to split the screen and see if we're able to do this. Let's see. So this is about the growth of functions. Do they have fit width scrolling? Yeah. And so here we can see, we'll grow this a little bit. Lots of text. And it says, let f and g be functions from the set of integers of the set of real numbers to the set of real numbers. Functions from the set of integers or the set of real numbers or the set of real to the set of real numbers. Okay, so I have to admit, this is why I'm not always a huge fan of this book, because it does get a little convoluted. We say that f of x is on the order of g of x if there are constants c and k such that f of x is less than some constant c times g of x whenever x is greater than k. And this is read, the f of x is big O of g of x. Intuitively, the definition f of x is on big O of g of x says that f of x grows slower than some fixed multiple of g of x as x grows without bound. Okay, so I feel like that is an important definition, and we're going to grab that. I'll grab clear down to here. So let's talk about constants c and k in the definition of big O notation are called witnesses to the relationship. To establish that f of x is big O of g of x, we need only one pair of witnesses to this relationship. To show that f of x is big O of g of x, we need to find only one pair of constants c and k, the witnesses such that f of x is less than some constant c times g of x whenever x exceeds k. Note that when there is one pair of witnesses to the relationship, there are infinitely many pairs of witnesses. To see this, note that c and k are only one pair of witnesses than any pair of c and k, where c is less than c prime and k is less than k prime is also a pair of witnesses. Okay, I feel like this is some good stuff, but my problem with it is I feel like it's a little hard to understand. And so I'm going to say from section 2, definition 01. Okay, I don't really feel like that answers it for me yet. So here it talks about the history of this. The German mathematician Paul first introduced the idea in 1892, well before computers. This is in a book on number theory. The big O symbol is sometimes called a Landau symbol, after the German mathematician Edmund Landau, who used this throughout his work. The use of big O notation in computer science was popularized by Donald Knuth. We'll learn more about Donald Knuth. Knuth? I actually don't for sure know how to say that name, but we'll read more about him more later. Okay, a useful, here we go. So I think this is going to be a useful example. So let's go ahead and let's grab this example. So I'll grab this. Nope. And I want to grab this little statement right here. The history is good, but I don't think it's relevant to the discussion, but I think this little blurb right here is. Okay. First, select a value of k for which the size f of x can be readily estimated with x greater than k, and see whether we can use this estimate to find a value of c for which f is less than c times g of x for x greater than k. This approach is illustrated in example 1. So here we've got the example 1, and it says show that f of x equals x squared plus 2x plus 1 is on the big order of x. So we observe that we can readily estimate the size of f of x when x is greater than 1, because x is less than x squared. It follows that 0 is less than x squared plus 2x plus 1, which is less than x squared plus 2x plus x squared, which is equal to 4x squared. Whenever x is greater than 1, as shown in figure 1, consequently, c can take 4 and k can take 1 as witnesses to show that f of x is on the order of x squared. Okay, so it's asking to show that f of x squared is on the order, f of x is on the order of x squared, and f of x is equal to x squared plus 2x plus 1. So essentially, what they're showing is you can use any value of x that you want. And then what they're saying is, all right, let's pick 1, because we know if we're using an x bigger than 1, then that's basically saying a starting point for where our graph is going to start. And that's this point right here in this graph down below. So that's our k value in this case, which is 1. And so here's our 1. And then we're using a c of 4. So let's take 4 times 1 squared. That's going to be 4. Now let's take 1 and times everything here. So 1 squared is 1, plus 2 times 1 is also 1, plus 1 is 4. So in this case, they're equal. But after that, we can see in the graph that the 4x squared is going to outrun it. Cool. All right, so now we've got this. We've got some idea. Assumptions. This is not going to be a great assumption, but I'm just going to write, so far, it looks like we can follow example 1. We are going to pick a point to start k, and then, and then we are going to pick a scaling variable. Okay, so let's go take a look what the first question is. So let's come down here and we'll have work. I'll do problem 7a. Now, just to make my life easier, and let's face it, I do that a lot whenever I'm possible. There it is. Okay, so problem 7a, I paste this in. Cool. All right, so it says, find the least integer n such that f of x is x of n for each of these figures. Okay. All right, so in this case, 1 is x squared times the log of n. So the log of n is going to grow slower than x. I'm sorry, the log of x is going to grow slower than x. So to show you what I mean, angry caps lock. Okay, so here's the log of x, base 10, and we know that x would be a straight line. So I'm going to grab this. And I'm going to go pop it in here. Okay. So we can see that log of x is going to be less than x for all, I think you can pretty much say for all x. Okay, now the second part of this. So that means two times x caret 3 is going to be bigger than x caret 2 times log of x. So we need to focus on the x cubed term. Oops, too many buttons. Control Z. Okay. Pick. Okay, so they're just looking for x of n. So we can choose n as 3. Okay, so basically what we're saying is the x cubed term is going to be dominant in this case, and I think that's going to be true after 1. So let's call BS on the old man. I think he's crazy. Let's go look in the back of the book. So how do we find that? Well, here's our student resources. Answer to odd number exercises. Sorry, it's taking a, you know what? Let's do this the other way. Bump, bump. Oh, it did pop up. Cool. A little more responsive now. So we need chapter 3. There we go. And now we're looking for 3.2. There's 3.2. And now we're looking for 3.2 problem 7. So I'm just going to grab this right here. Okay. Oh, that's weird. All right, that'll work. Okay. I'll throw this in there. So the choice of C and K are not unique. Where does it ask about that? It says 7, find the least integer n such that f of x is 0 is for these functions. And there's no mention of C in this, my friends. It says n equals 3 and C equals 3, K equals 1. Okay, so let's talk about that for just a little bit. Okay, when you're looking at this, if we're looking at x cubed and we plug in a 3 for, or I'm sorry, they're saying if you plug in a 1 for k, all right, the log of 1 is going to be 0, so this term goes to 0. 2 times 1 cubed is going to be 2. And what they're saying is if you choose k of 1 and c of 3, well, x cubed, if x is 1, is going to be 1, times 3 is going to be 3. And so I don't have a pretty graph to draw for you right quick, but 3 is greater than 2, and then it's x cubed is always going to be getting bigger. Okay, so I'm okay with that. So why we believe our answer for 7A So basically, the back of the book is telling you that they're actually looking for more information than what they're giving you when they're asking the question. And so, I mean, that is one of the tricky things, but that's why I like to give everybody all the answers up front, is so you can kind of see this part of the discussion. Okay, so now we've got part B. So I'll come up here and I'll come down here. Part B, and I'll do 7B. Oh, goodness. There we go. 7B. I'll just grab this little nugget right here. Okay. So let's drop in 7B right there. Make this a little bit harder to read, easier to read for me. Okay. 3 times x cubed plus the log of x to the fourth. So the question is, which one of those is going to grow faster? All right. So I don't have a great way to answer this, but one of the tools that I always used in my youth is what they call a t-table. So I'll see if I can split this screen and make this work. Okay, so I'm going to do x, and I'm going to do 1, 2, 3, 4, 5. Cool. Now I'm going to do 3 times x caret 3. Okay, so this is equal to this number. Actually, let's do this. Let's do 3 times this number. But we need to change this just a little bit. And I wish the font was not quite so small on this. Okay, but it's going to be, I don't know if you're that clever. We'll find out if it is. So, yeah, that'll work. No. Okay. Okay, 2 squared is 2 cubed is going to be 8. 8 times 3 is 24. Cool. 3 cubed is going to be 27. 27. Okay, I'll take that. That's working. Okay. Now I'm going to do log of x. Oh, come on, kids. Something like this. So this is going to be equal to log of this, and I'm gonna give it, just use a base 10, and then I'll drop in the exponential again. Yeah, let's go ahead and do that. All right, so what this shows, and as expected, so log base 10 of 1 is 0, so that's still cool. These are still very, very, very small numbers. So even though this has a higher exponent, this is going to be a shorter value, so we can focus on this. So I'm going to use a C of, let's just use a C of 4. 4 times x caret 3. And so this is going to be equal to 4 times this cell raised to the third power. So check this out. 32, 108, it's always bigger. So I'm going to say that we can use a k of 1 in this case. So I'll make that bold. And that I can use a C of 4. So I'll make this italics. So I'm just going to grab this little table right here. I'm going to come in here and we'll paste that in. Okay, so now that I did that, now I'm going to come in here and I'm going to say, so I want a C of 4, K of 1, and an N of 3. Okay, so we can scroll up. Here's the answer to B. So n equals 3, yay. C equals 4, yay. K equals 1. Now, when they were talking about we can have an infinite number of possibilities, there's some very inappropriate humor that we could use to kind of help put this in perspective. Let me put it a different way. You know how some people have like an older sibling? Like my older brother is 2 years older than I am. Not quite a full. It's like his birthday is 9 days, or I'm sorry, 9 days after mine. And so technically he's 9 days short of being exactly 2 years older than I am. Now, we can pick whatever point in time after both of us were born, and he's always going to be older than I am. And so what that means is my age is always going to be bound by my older brother's age. And what we're saying here is for x to the third, 3x cubed, 3x cubed is always going to be bound by 4x cubed, especially if we're talking about starting with a k of 1. So a starting point value of x is 1. If we're using a c of 4, so we're multiplying x cubed by 4, 4 times x cubed is always going to be bigger than 3x cubed. All right, so this is what we're talking about, and hopefully this makes a little bit more sense. I'm going to cheat just a little bit, and I'm going to skip. Actually, I won't skip. I'll just go over it briefly. Okay. This is a bunch of gunk. We've got x to the fourth plus x squared plus 1 divided by x cubed plus 1. Okay, hand waving aside, I think this is going to be x to the fourth divided by x cubed. So x over 4, or x to the fourth, 4 minus 3 is 1. So I'm going to say n in this case can be 1. And I'm guessing they still use 1 and 4. Let's go check the answer that they give. So here we go. Part C, n equals 1, because x to the fourth minus x to the third is 1, x to the 1. And this time they use a c of 2 and a k of 1. Now, I call BS, right? Because I got no idea how they did that funky math. I think Everett was doing way too much stupid hand waving. And so let's come in here, and I'm going to call this problem 7B. I'm going to call this problem 7C. Okay, let's call this chapter 03, section 02. All right, let's just share that. Go ahead and now everybody can view it. Let's pop over here. There we go. Announcements. Actually, we'll come in here to the syllabus. We'll come down here to the schedule. And we'll just paste this in here. Cool. Now everybody's got access to it in the syllabus. Okay. Like I said, I'm going to call BS on this one. I don't trust Everett. I think he's gone off the rails too far. I think I need to see a little more evidence. Okay, so I'm going to say x1 equals 1 plus 1 up above it. Drop it down. Cool. And now, apologize. Let's get this. We're coming for 7C. And so this is going to be x caret 4 plus x caret 2 plus 1 divided by, yep, whoop, there we go. Hey, now, friends, settle down. x caret 3 plus 1. Cool. And so the way we are going to look at that, I'm going to say equals this number, caret 4, plus this number, caret 2, plus 1, divided by this number, caret 3, plus 1. Cool. Absolutely, that's brilliant. I'm noticing that this is not growing too fast, right? So I'm going to say, let's say 2 times x. So this is equal to 2 times, and yeah, autofill. Okay, so starting with a witness of 2 and a C of 2 and a K of 1, we can see 2 is bigger than this, 26 is bigger than this, and at no time do they cross in between. Okay, so maybe that's not so crazy. And we can do a similar thing for 7 part D. We can just use the t-tables, and we can do the same thing for 8, all these other individual ones. It's just, taking the time, set up a t-table, and then go ahead and go through it. You could use 4 and 1 for all the witnesses, C of 4 and a K of 1 for all the witnesses, and it would have worked fine. Really doesn't make that big of a difference. But the t-tables for me just kind of make it easier for me to see that. And so that's what I kind of expect you to do on the rest of these. I'm going to go ahead and stop short. I assume that everybody's able to figure out their favorite Excel spreadsheet or programming language, whatever it is that you want to use to go do this. And so you can get started on that. So what I want to do now is I want to bop back over here to part C. To part 9. So just to review my estimation, this one is going to be x cubed times a smaller number. So I'm not sure which one of these two is going to dominate. I will say with confidence that in part B, the x to the 5th is going to dominate. In this one, I think you might be able to get away with a 0, possibly, because x to the 4th divided by x to the 4th, you might be able to get away with 0. And then part D, it looks like you can get away with possibly even a -1. Okay, so I'm going to go ahead and share this, make it so everybody can view it. I'll copy the link, come back here, I think it was, and Alt-Enter, paste again. So there's 2 different links in here, and I'm going to say change that. Okay, do you know? Yes. All right, so now I'm going to change this, and I'm going to say this doc. Did you update F5? You know what? That's okay. Let's go back here right quick to student resources, even answers, and go down to 3.2. Here's problem 8. So I'm just going to grab this. I'm going to go paste it in the, that's not the one I wanted. That's the one I wanted. Okay, so where do we have? Yeah. Okay, I'll paste it in here. That's not going to work. Is it? Let's take a look. That's not good. Okay, let's try again. Paste. Okay, I don't think I'll be able to do this. No, let me try something different. No. It's just getting wonky on me, and I don't really understand why. But I can do this. So whenever you make a copy of a copy, it's never as sharp as the original. So let's try it anyway. Okay, so that's a little more legible. All right, so the question on part A, because the log of factor x grows without bound, so n equals 3 is too small. On the other hand, certainly log of x grows more slowly than x, so 2x squared plus x3 log of x is less than 2 of 4, so 3 of x, therefore their n is going to be equal to 4. Okay, so the question was 2x squared plus x cubed log of x. And so they're just saying, all right, x to the fourth is bigger than x cubed log of x. So if we had x cubed times x, that's actually x to the fourth. X cubed, I think they should have been able to get, oh yeah, this one. So x cubed times log of x is just slightly smaller than x to the fourth. And that's what they're saying here. Okay. And again, they have a nice discussion on all of these. Now, what I'm going to do is I'm going to bop down here and I'm going to say question 9. All right, so what was question 9? Make sure that we get it right. No, that might have been right. Nope. Too many tabs, my friends. Well, let's just grab it from here. It'll be a little ugly, but we'll get it done. Okay. S. It says, okay. So question 9, paste this in. I'm going to shrink it down just a little bit so it fits easier. Okay, so it says to show, I'm going to drag this over to this other screen, and I'm going to zip back here to this one. And I'm going to do a new tab. And I'm going to say problem 9. Okay. So I'm just going to pick x, and I'm going to say 1 equals 1 plus this. And let's just drop this down to truckload. Okay. So it says the first one is going to be x squared plus 4 times x plus 17. Okay, and there's some dandy stuff that you can do with limits, but we're going to do it this way. Equals x squared plus 4 times x plus 17. Yeah, autofill looks great on that. Okay, so 17 plus 4 is going to be 21, plus another 1 is going to be 22. I'll buy that. X squared, 2 squared is going to be 4, plus 8 is going to be 12. 12 plus 17 is 20. Okay, yeah, I'll go for that. So we need a witness for on the order of x cubed. Okay, so let's just use a C of 2, x caret 3. So this is going to be equal to 2 times x caret 3. And yeah, let's go ahead and fill that down. So 2 doesn't quite get us there. I'll just make it 20. And so that means you need to be a 20. And go ahead and drop that down. You know what? I shouldn't have done 23. I can probably just do a 2. And I'll just make this a 2. Okay, so as far as my k value, I'm going to say k equals 3 for c equals 2, right? And so we can see that that's this level right here. Okay, now then, it says we want to show the x cubed. Okay, so now we're going to do, I'll just grab this row right here. Come on, kids. Now, there's our x, and here's x caret 3. And so equals this to the power of 3. And autofill looks great. Now we're going to do x caret 2 plus 4 times x plus 17. Okay, and so this is equal to caret 2 plus 4 times x plus 17. Did I get that right? So it's the first cell squared. By the way, what's my zoom set out on this? There, I can see slightly better now. Okay, so the first one squared plus 4 times the first one times 17. I like it. And now I can do the drop down. Okay, so I'm going to pick for this case, actually, make you not bold, make you bold. And I'm going to say, so k equals 4, c equals 1. So using this witness, or this pair, c is 1, so it's 1 times all of this, and starting at x equals 4, we can see that x cubed is always outperforming it. So what this says is that it's not a reversible relationship. Let me say that differently. If you can easily pick multiple pairs where the steepness of the curve for x cubed is going to go up faster than x squared. But you can't pick a range for c and for k such that x squared is going to consistently outperform x cubed. The slope of x cubed is x cubed is going to go up faster, x squared is going to go up slower. And so see if I can get my arms to do. Actually, I can't bend my arms that way. But basically the idea, x cubed is going to climb faster after a certain point than x squared. And that's what big O notation is kind of trying to get us around. So friends, I'm going to go, well, let me just verify that the old man's not completely crazy. Drag this back. Oh, yeah, it's this one with the PDFs on it. Answers to evens. All right, so here's what they have to say. They say x squared is less than 3x cubed for all x greater than 17. Now, we actually found that if you just pick 2, you can get away with about a k of 3. So instead of 17, you could have done 3. They were getting extremely lazy. They didn't actually plot this. So x, that's true, with witnesses of c equals 3 and k equals 17. I question that they needed to go to that big of a number. I think they could have got away with 2 and a much smaller number than 17. Personal preference. So it is. However, if x cubed were on the order of that, then c for all sufficiently large, which implies that x is less than or equal to 3c, which is impossible. Hence, x cubed is not. Okay, so they said it a little differently in Matthews, but basically what I'm telling you is you've got 2 different curves. You've got the x squared curve and the x cubed curve. X cubed is going to have faster growth. So you might be able to outrun x cubed for a little bit, but eventually x cubed is going to outrun x squared for a sufficiently large x. All right, friends, this does get a little bit confusing. We're talking about limits. We're talking about behavior. I like to slow things down and put these things on what I call a t-chart and just kind of compare the 2 numbers apples to apples. Hopefully it's not too terribly concerning. Hopefully you're able to have some fun with it. I appreciate all of your time. I look forward to working with you in the future. If you have any questions, let me know. Also, it was brought to my attention that we might be changing the homework assignments back to a discussion instead of everybody just kind of standing on their own. I had a lot of positive feedback about that from the first homework assignment, made it a lot more approachable, especially for people that are struggling a little bit. So we might be looking to do that on homework 3. Homework 2 is going to stay the same. Homework 3, we might be switching things over. Anyway, watch for that discussion later. I hope you all are having a wonderful week, and I look forward to working with you real soon. Thanks you all for your time. Take care. Bye.